Hey, it's Professor McStud here. We're going to continue talking about quadratics and solving them. So when we solved them before, we found doing that through factoring. Well, what happens if it's a prime? You can't factor it. So what happens then? You just can't solve it? No, there's another way for you to solve it, and you use the quadratic formula. That is this here. You do not have to memorize this. This will be given to you on your formula chart, but you do have to know what B, A, and C are. Well, that comes from the standard form we've talked about. So it kind of sort of goes along with the B and the A from the axis of symmetry formula we looked at. So when we look at this, we have example 1, 4x squared minus 5x minus 12. A is 4, B is negative 5, and C is negative 12. So then I go back and plug it in. So I have x is equal to negative 5. I go ahead and write that just so that way I don't get confused. Plus or minus, that's what that means. So we end up doing essentially two equations there towards the end. And then we have the square root of b squared, so negative 5 squared, minus 4 times negative 12. All of that divided by 2 times 4. Now, what is this part right here underneath the square root? That's called the discriminant. We're going to talk about that a little bit later on, but that discriminant has to be positive because you can't find the square root of a negative number. So that just kind of a little heads up on that one. So then I can go through here and kind of sort of do some, I guess, simplifying. So I have 5 plus or minus. I'm going to do the whole discriminant together and then divide that by 8, and then we'll see the two so I'm going to do the discriminant in the calculator, and then we'll see the two equations. And so the discriminant here is 217, so it has to be a positive number. Now, I know that you're saying, well, I can't think of something that multiplies by itself to get to 217. Well, 217 is not a perfect square. So what we will end up doing is we have two equations here. We have one from this point. We will have 5 plus the square root of 217 divided by 8, and we have another one. So this is x. Remember, we had two answers when we factored. And then x is equal to 5 minus the square root of 217 divided by 8. I would put this all in the calculator at once at this point. You can technically put this whole thing right here in the calculator, but I definitely wouldn't because there could be some error. So the less things that you're putting in a big chunk at a time, the less, error that you have. So let's put this in the calculator. So you have 5 plus the square root of 217 and then divided by 8, and that's going to give you 2.46. So x is equal to 2.46, and then the same thing with minus. And we are going to get x is equal to negative 1.22, rounded up. So those two are our answers. So this is your answer and that is your answer. So we're finding the solutions, finding the answer. We're solving quadratic equations through the quadratic formula. The other way you can do it is that you can factor them. But I can't find two factors that multiply to 48 and multiply to negative 48 and add to be negative 5. So that's why I have to do the quadratic formula route. You technically can do the quadratic formula for ones you can factor, and they come out to be a nice pretty number. But I think factoring is easier, less room for error. Again, that's kind of sort of your preference on this, a little bit like systems, and that you can choose which system you like or which method you like better. So let's look at the second one. You'll notice here that I don't have 0 on one side, so I have to make it there. Now, I know that before I said I like to keep my coefficient in front of x squared positive. I still like to do that. So I'm going to move 8x and 7 to the other side. So I'm going to subtract 8x and subtract 7 from each side. That gets me the 0 on the right. Then I'm left with 2x squared minus 8x minus 7. So therefore I'm left with 2, negative 8, and negative 7. Go in, plug that into my quadratic formula here. So x is equal to negative 8 plus or minus the square root of my discriminant, which is going to be negative 8 squared minus 4 times 2 times negative 7. All of that divided by 2 times 2, 2a. So I'm using my quadratic formula, just plugging straight in A, B, and C. Now then, I'm going to simplify my discriminant in the calculator. So I have 8 plus or minus the square root of my discriminant divided by 4, which gets me to 120. My discriminant is 120, so positive number again. Nothing multiplies by itself to get 120, so therefore I'm going to have another little decimal part here. So remember, I now break up into 2 equations. And so I have x is equal to 8 plus the square root of 120 divided by 4. And then my other equation, I'm going to move it over here, is x is equal to 8 minus the square root of 120, all that divided by 4. Plugging all of that part into my calculator there. Remember, using a fraction, so control divide gives you the fraction on the calculator. So that's another helpful part of make sure you are putting this in correctly. And so I get 4.74 for this first one. So x is equal to that. And then the second one with the 8 minus, then I can see what that is by putting in my calculator. And I end up with x is equal to negative 0.74. So those two would be my answers here. Bam, bam, bam. So I didn't have much room to write, but so that is solving quadratics through the quadratic formula. Remember, the other way is through factoring. That's if it's factorable. So what if it's not factorable? How can I solve this? It means there's no solutions. No, there are still solutions, but here we have a little bit different method of using that. So that's what I have for you, quadratic formula, kind of a little introduction. Again, you don't have to memorize the quadratic formula. It will be on your formula chart, but it might be helpful to write it at the top of your page so that way while you're working problems, you can just look at that very quickly. That's what I have for you.